All right, so today we are talking about scatter plots. I already wrote scatter plots in the front in the table of contents on page 60. And then I turned to page 60, wrote it in the bottom right-hand corner, titled it, and put the date. So as you can see, we are back to 8th grade standards. 8th grade SP 1.1, statistical probability. The learning goal reads, investigate patterns of association between bivariate data. So we're investigating patterns. We're analyzing different patterns we see, different relationships between bivariate data. Bi, two, just like two wheels on a bicycle. Variate, variables. So we're going to be looking at data that's comparing two different variables. So scatter plots. Scatter plots show 4 different types of relationships. We use scatter plots to show 4 different types. 1, 2, these both are the same type. 3, and 4. 4 types of relationships. So when you are looking at a scatter plot, you are thinking, can I draw a line through it? Now this line that you draw through scatter plots is called the line of best fit. So it like fits the best. Can you draw a straight line through this? Yeah, it would just go right through it. Now, what type of relationship is this? Well, what kind of slope does it have? If you're down here, are you running up it? So it's increasing, positive in difficulty, or are you running down it, where it's decreasing in difficulty? You're running up it, left to right, you're running up it. So it has a positive slope, and you could draw a straight line through it. So this scatter plot shows a positive linear relationship. Positive because it's a positive slope. Linear because you could draw a line through it, and it's a relationship between the x and the y axis, or the variables that it'll be representing. Okay, the next one. Is it positive or negative? Well, we read graphs left to right. So if you were a little person up here, would you be running down? Would it be a negative? Would it be decreasing in difficulty, or would you be running up the graph? You'd be running down it. It's decreasing, so it's negative. It's going down, it's negative. Again, we could draw a line of best fit through this. So it's a negative linear relationship. Okay? Now, these two. Can you really draw a line through either of them? Okay, well, this one would definitely be a curved line. So that's not a straight line. That line does not have a constant slope or constant rate of change or constant steepness. It changes. This one, increasing, increasing, increasing slope, levels out to flat, and then decreases. So these show that there's definitely a relationship between the variables. There's definitely some type of line we could draw through it, but it's not a straight line. So when it's not a straight line, but there's still a relationship, it's called a nonlinear, so it's not a line, nonlinear relationship. So let's talk about each of these 3 so far. The first one, as the x values increase, the y values increase. So this type of graph could represent, like the x values could be miles driven on a road trip, and the y-axis could be gallons of gas that you've had to buy. So as you drive more miles on the road trip, you have to fill up and get more gallons of gas. So it's a positive relationship. That means as one increases, the other increases. It's a direct relationship, direct variation. They both increase at the same time. The next one's a negative linear relationship. So that means they're inversely related. That means as one increases, the other variable decreases. So for example, as one increases, so the more money that you put in the bank, the other decreases, the less debt you're going to have, or the less money you're going to have to owe. So it's an inverse relationship. It's a negative relationship. Then nonlinear relationships, it's still related, but it's not a straight line. So for example, this second one could be, the x-axis could be months of a year. So January, February, March, April, May, June, July, August, September, November, December. And then the y-axis is Sundays sold. So it could be, it's increasing as the year goes on because it's becoming warmer. It's in the summer, so we're selling so much ice cream. And then it decreases as we get back to winter and it's colder. Not as many people are buying ice cream from the ice cream truck. So there's different relationships between the variables. The last one, it just kind of looks random. There is no relationship. There is no line you can draw through this, regardless if it's a straight or a curved line. There's no relationship. So that could be like, the older you get, the number of pets you own. A 2-year-old is just as likely to live in a family that owns 10 cats as a 75-year-old lady. There's no relationship. It's not like as one increases, the other increases for sure, or decreases. Okay, so now we're going to do a couple of examples. So this is already kind of just talking about your first Khan Academy assignment. You're just analyzing what kind of relationship the graphs show you. The other one, now we're actually going to kind of analyze the graphs more. So the first one we're going to draw together, and then the other two you're going to look at the handout I would have given you in class. So example. Okay, we're going to have a graph and it's going to be titled TV size / price and price. And guys, just because I already had my graphs drawn doesn't mean you don't need to draw them. You should still have these in your notes. This is stuff you can study. We are going to be having a test the week after this. Okay, so you can obviously use your notes, but if you don't have them, then they're not going to help you. Or it's going to take you a lot longer to find the material. So we're going to do TV price. Let's do $6,000, $5,500, $5,000, $4,500, $4,000, $3,500, $3,000, $2,500, $2,000, $1,500, $1,500, and 0. So the y-axis is going in increments of $500. So this is the TV price. TV price in dollars. Okay? And then we have the x-axis, which is going to have TV size. So 10, 20, 30, 40, 50, 60. So not only are we practicing interpreting and reading scatter plots, but we're also making one right now. So then you would have a list of data that would tell you, okay, here's the size of the TV, and here's the price. And then you would just plot it like X and Y coordinates. So I'm not going to expect you to just plot this perfectly. I'm just going to put dots to mimic the graph that I see. It does not have to be perfect. We're going to have some dots around here. And then we're going to have dots more in the 50s, 60s around here. And then we're going to have dot right here. Okay. So your graph should look like this once you're done. So let's talk about it. First of all, what is going on in this graph? What do we notice? What kind of relationship? So it kind of seems like we could, it's kind of like a curve, but it also seems, maybe I should have done more here, like you could draw a straight line through it if you ignore this one. You could kind of draw a straight line right here. And it's we read graphs from left to right, just like a book. So if we were down here and we were running, we'd be running up it. So it's increasing in difficulty. So it is a positive, as a positive slope, positive linear relationship. Okay, you guys should kind of already know if it's positive or negative, because we've done a lot with slope and lines. So this should be a refresher just now with a scatter plot. So it's a positive, it's increasing in difficulty, linear, it's a straight line, relationship. There is a relationship between TV size and TV price. That's our bivariate, our two variables, TV size, TV price. Okay, but now let's talk about some words you heard last year. Okay, let me get a different color. Outlier. Outlier. We talked about this also before spring break. What's an outlier? Well, it's someone who doesn't belong. They don't really fit in with the pattern. Okay? An outlier, if we're doing the ages of students in our class, and like we said, oh, I had red pen on my finger and I thought I was bleeding. Okay, and then President Trump walks in, all right? Or George Washington, and he's back from the dead, okay? Obviously, his age is an outlier. He's much older. So the outlier here, this dot right here, does not fit the pattern. That dot says when the TV is 50 feet, isn't that what we do TVs in? Yeah, feet. So when the TV is 50 feet, it's going to cost $5,000. So we have an outlier at $55,000. That dot does not fit the pattern. So that's our outlier. All right, next we have a cluster. Cluster, what is a cluster? Okay, a cluster is when you have a lot of dots kind of in one little area. All right, picture in the mornings before school, you guys are kind of all dispersed into little clusters with your friends, okay? You're in little packs of a few students, and then there's some space, and then there's a cluster of another friend. So we have our cluster right here. It's where all these dots just kind of go together. So it's from like, what, 28 to 38 feet? So we have a cluster at 28 to 38 feet, or what? I'm just eyeballing it. $200 to $1,200. $200 to $1,200. As long as you can identify where the cluster is, you're good. So there's a cluster of dots right there. Where this is too long, that's not really a cluster. This is just like a little group in one little section. So that's cluster. And then the last word I want to talk about is gap. Gap. So do we have any gaps? You guys know what a gap is. Picture someone with a gap in their teeth. Okay, then you get braces. So we have a gap. If I didn't draw this line, you would have seen it. We have a gap right here. This is a gap. It's blank there. Okay, we don't have any dots here. Yes, we have the line I drew, but that line wouldn't technically be there. So we technically have a gap. Gap. Just drawing lines. Cluster. Outlier. So we have a gap from 38 to 48 feet. Or we have a gap. So from 38 to 48 feet, maybe that's not a really popular size of TVs to buy. Or what's the price range where the gap is? The gap. It's like $800 to $1,000, I don't know, 700, 750. I'm just eyeballing it. But what's important is that you can be like, okay, that's an outlier, doesn't belong. That's a gap, there's a space between the dots. That's a cluster. That's where they all cluster up. Okay, so now we're going to do the two practice problems I would have given you in class. So obviously you do not have these. Feel free to write down the problems, draw them in. But I want to go over these. Sorry, I got some pen on that. Okay. Number 1. Which statement is the best description of the association between these variables. So we're describing the association, how they're related between these variables. The degrees in Celsius of the temperature and the amount of gas used. So, we read graphs from left to right. This graph is decreasing, okay? Because we read them from left to right, so if you were a person, you'd be running down it. So it is it positive or negative if you're running down it? Negative. It's a negative. We could draw a line through it, so it is linear. It's a negative linear relationship. Okay? A, as the temperature increases, the amount of gas used increased. B, as temperature increased, the amount of gas used decreased. C, there is no clear relationship between temperature and gas used. So I want you to pause the video and actually analyze the scatter plot. Think about which one do you think is the right answer choice. Actually do this, guys. Okay, so immediately I eliminated C. It says there is no clear relationship. There is a clear relationship. We could draw the line through it, the line that fits best, the line of best fit. There is a negative linear relationship. So now it leaves us with A and B. As the temperature increases, so we're increasing in temperature, the temperature is getting higher. So as we move right on the graph, the amount of gas, does it increase or decrease? Well, to start with, the amount of gas used is up here. But then, as we keep going, it's a negative relationship, so it's dropping. So as the temperature increases, the amount of gas used, it's decreasing. When it's a negative linear relationship, as one variable increases, the other decreases. So the answer is B. If you actually paused your video and got it right, please let me know. I would be so proud of you. Okay, let's do the second example and then we are done and you guys are ready to do both of your con assignments. So, just look at the second graph. Determine what type of relationship do you think it is? Positive linear, negative linear, nonlinear, or no relationship? Which one? So when I look at it, I kind of see like a mountain or a hill. So to me, there is a relationship, there is a pattern, but it's not a straight line because it curves. Throwback, is it a function? Does it pass the linear line test? The vertical line test? Yes, it is a function because we never touch more than one dot at a time. But it's not a straight line. Okay, it curves, it turns. So what was that called? Is it a straight line? No. So it's a nonlinear relationship. Why is it a nonlinear relationship and not no relationship or no association? Well, no relationship means that there's not a pattern. There clearly is a pattern. It's just not a straight line. All right, so Nate wants to predict how much people use the internet each day based on their age. So based on their age, how much are they using the internet? The graph below shows the age in years and the average daily internet usage in hours for a sample of people. Which statement is the best description of the association between these variables? So, literally pulled off the learning goal. We are describing the association between these variables, the bivariate data. There's two variables, age and internet use. A, as age increased, so as we got older, the internet use always increased. So the internet use always increase. B, internet use was highest for those between 20 and 35 years. 20 and 35 internet use. C, none of the above. What do you think it is? All right, say it out loud. 1, 2, 3. I hope you said B. So, A, as age increase, internet use always increase. If that were the case, it would have been a positive linear relationship. That it would just keep increasing. So no. C is if B is not true, but B is true. B, internet use was the highest for those between 20 and 35 years. Well, yeah, as you guys get older, you use more and more internet. Think about 20 to 35-year-olds, they're working all the time, they're always on their phones, they're on social media, they're filming their next TikTok, all right? And then, as you get older, you don't really use it as much. Especially, they took this sample at one time. So especially older people, they're not as comfortable with technology, and also they're not as addicted to it because they had a life without all the internet and smartphones. So the answer is B. Internet use was highest for those between 20 and 35 years. It makes sense, and also the graph shows that those are the highest points. So I hope after this video you feel better about analyzing scatter plots and describing the relationships between two variables. I'll see you next time. I miss you guys dearly, and yeah, bye.